So let's look at a numerical today, and this will be our first tutorial class. In our first tutorial class, we will look at a numerical relating to the calculation of factored or design loads. We have already discussed about what are characteristic loads and what are design loads in our previous lecture. We will look at a numerical today relating to that. So here we have a question. A one-way slab for a public building is 200 mm in overall thickness. So let's consider we have a slab here with overall thickness of 200 mm. It is simply supported on a span of 4 meter. Let's say this is the span of our slab, 4 meter, and it is simply supported at the edges here. And loaded with a live load of 3 kN per meter square. Determine the factored moment and factored shear for strength design and the loads for checking serviceability. So you have to determine three things here: factored moment and factored shear force for strength design and the loads for checking serviceability. So before design or determining factored moment and factored shear force, we have to determine the design loads, and before determining the design loads, we have to know what are the characteristic loads. So we will begin with calculation of characteristic loads here. So you can see from the question that there are two types of loads given for this slab. One is the dead load and another is the live load. Do not stress your mind on what is this one-way slab or what these simply supported means or what the span is. We will discuss about these in detail during the design of slab class. We will just look at the calculation of loads in this numerical. So first, to determine the dead load, you should know the unit weight of concrete, that is reinforced cement concrete. So we will assume here that the unit weight of RCC is taken to be 25 kN per meter cube. So this is the general unit weight of concrete, reinforced concrete, that we will be using. So our dead load we will determine as area load, because our live load is also given as area load here, 3 kN per meter square. So this dead load we calculate as unit weight multiplied with the thickness of slab. So our unit weight is 25 and the thickness is 200 mm, that means 0.2. So 25 into 0.2 comes out as 5 kN per meter square. And the live load we have been given is 3 kN per meter square. So we have got our characteristic loads here. Using these characteristic load, let us determine the factored or design load. It is called factored because we multiply these loads by partial safety factor. So let us say that this factored load is represented as W here, and the value of this factored load is given as 1.5 dead load plus live load. This is one of the load combinations that we discussed in our previous lecture. Always this load combination may not be suitable or may not be governing in the design of this slab, but this is the general load combination that we will be using to determine the factored load in case of gravity loads, because this dead load and live load both act in the direction of gravity. We will use this load combination for our gravity loads. If you don't remember, this was given in table 18 of IS 456 2000. You can look at this code here. So our factored load becomes 1.5 into dead load is 5 plus 3. So 1.5 into 8 means 12 kN per meter square. So our total load was 5 plus 3, 8 kN per meter square was our characteristic load. Our factored load comes out to be 12 kN per meter square. Now we will use this factored load to calculate the factored moment and factored shear. So how do we calculate first factored moment? You can just say moment also, because we have already used factored load here. So whatever we will calculate using this factored load will be factored, that is either moment or shear. So factored moment, since we have a simply supported slab here, the formula for the moment in a simply supported slab is WL square over 8. So W is the factored load, which is 12. L is the span, which is 4. So 4 square divided by 8. You will get the factored moment to be 24 kilonewton meter. And our factored shear force will be, let's write SF. The value of shear force in a simply supported slab is given by the formula WL over 2. So 12 into 4 over 2. That means 24 kilonewton. So we have got the two values here. This is the factored moment and this is the factored shear force. Now, one final thing to calculate is the load for checking serviceability. So how do we calculate the load for checking serviceability? For this, we will again see table 18 of IS 456, and we know that if we have used this load combination here for determining the factored loads for serviceability condition, this partial factor of 1.5 will be changed to 1 only. Since our load combination for serviceability condition WS is represented by 1 dead load plus live load. The factor of safety is 1. So 1 into 5 plus 3 is given as 8 kilonewton per meter square. So our numerical is complete here. We have calculated the factored moment and factored shear for strength design, that means using this factored load combination here, and then we have calculated the load for checking serviceability. You can see that the factored load is always greater than the load for checking serviceability. Since we check serviceability using the working loads, that load or that magnitude of load will be lesser than the factored loads that is used here. So this is our numerical. We have completed it, and we'll meet again soon in our next lecture. Till then, stay safe and thank you.